Picture a bustling steel plant, an environment alive with energy, where the air shimmers with heat, machinery rumbles constantly, and every movement is a dance of precision and timing. Here, workers move purposefully among glowing furnaces, surrounded by the thunder of heavy equipment and the constant hum of industry. On what seemed like just another ordinary day, something truly unexpected happened. The carbon electrodes inside an electric arc furnace, which are supposed to slowly wear down with use, began to do the opposite. They started growing, getting longer instead of shorter. It was as if the rules of the plant had suddenly changed. Imagine if, every time you wrote with a pencil, instead of the tip wearing away, it magically grew longer. That's how strange this phenomenon seemed to the workers and engineers on the floor. The electrodes weren't just growing, they were coated in a mysterious black, fluffy material that no one had seen before. It clung to the surface, soft and powdery, almost like soot, but somehow different. At first, everyone thought it was just another maintenance issue, a strange residue to clean up, another puzzle for the team to solve before the next shift. But curiosity soon took over. What exactly was this odd material? Why was it forming now, and what did it mean for the plant's operations? The engineers couldn't let it go. They had to know more. As they dug deeper, the team realized that the intense heat inside the furnace was doing something remarkable. It was breaking apart methane from the natural gas supply, splitting it into its basic elements: pure, solid carbon and hydrogen gas. This was a chemical reaction happening right before their eyes, hidden in plain sight. This accidental discovery was more than just a curiosity, it was a hidden treasure. They had stumbled upon a way to produce hydrogen gas without releasing any carbon dioxide into the atmosphere, a process that could revolutionize clean energy. The black fluff was actually pure carbon, a valuable material in its own right, and the other product, hydrogen, is one of the cleanest and most powerful fuels known to science, capable of powering everything from cars to entire cities, all without polluting the air. Suddenly, what started as a quirky maintenance issue had become a scientific breakthrough. The team realized they were on to something big, something that could change the way the world thinks about energy. This was the spark that led to the founding of Tulum Energy, and soon after, a $27 million investment to turn this accidental discovery into a world-changing technology. Investors and innovators alike saw the potential to reshape the future. What began as a strange observation in the noisy chaos of a steel plant became the first chapter in a clean energy revolution, one that could help solve some of the planet's biggest challenges. Sometimes the biggest discoveries come from the smallest surprises, a detail overlooked, a quirk in the machinery, a moment of curiosity that changes everything. This was just the first step on a journey to transform how we make hydrogen, opening the door to cleaner industries, greener cities, and a more sustainable world. And to think, it all started with a growing electrode, a simple accident that sparked a revolution in clean energy. So, what was really happening in that furnace? The answer: methane pyrolysis, a process that's quietly revolutionizing how we think about energy and emissions. Methane, the main part of natural gas, is a molecule made up of one carbon atom bonded to 4 hydrogen atoms. Its chemical formula is CH4. This simple molecule is found in abundance and is a major source of fuel for heating, electricity, and industry around the world. Pyrolysis is a special chemical process. It means using extremely high heat, but crucially, without any oxygen present to break molecules apart into their basic building blocks. This is different from burning, which needs oxygen and creates carbon dioxide. Imagine a super hot oven, temperatures soaring above 1000 degrees Celsius, where methane is blasted apart by intense heat. Inside, the methane molecules are split into their components, all without a single spark of flame or puff of smoke. In this process, the carbon and hydrogen atoms go their separate ways. The hydrogen atoms pair up to form clean H2 gas, a fuel that burns with 0 emissions. Meanwhile, the carbon atoms clump together, forming a solid material. The absence of oxygen is absolutely key here. No oxygen means there's no way for carbon dioxide to form. This is what makes methane pyrolysis so different from traditional combustion or even steam methane reforming. Instead of releasing CO2 into the atmosphere, you get solid carbon, often called carbon black. This carbon can be collected, stored, or even used in products like tires, inks, and batteries. This process is a clean trick. Out of one methane molecule you get 2 valuable products: hydrogen gas, which is in high demand for clean energy, and solid carbon, which has many industrial uses. The chemical equation is simple. CH4 breaks down into C plus 2H2. That's one carbon atom and 2 molecules of hydrogen gas for every methane molecule processed. No carbon dioxide is made in the process itself. The air coming out of these facilities is clean, with no greenhouse gases released from the reaction. That's why this discovery was so exciting for scientists and engineers. It offered a way to make hydrogen a clean fuel without the usual climate cost. It's a way to make hydrogen from natural gas, but without the greenhouse gas emissions that usually come with it. This could be a game changer for industries looking to go green. Methane pyrolysis could help decarbonize our entire energy system. By producing hydrogen cleanly, it supports everything from fuel cell vehicles to renewable energy storage, and even cleaner steel production. It's a simple, elegant solution to a complex problem: how to keep using our existing resources while cutting down on emissions. Clean hydrogen, useful carbon, and no CO2. That's the promise of methane pyrolysis, a process that could help us transition to a cleaner, more sustainable future. That's the magic of methane pyrolysis. It's a blend of chemistry, engineering, and a bit of luck. And it all started by accident. A fortunate discovery that could help shape the future of clean energy. Tulum Energy took this accidental discovery, an unexpected event in a steel plant that could have easily been overlooked, and saw its potential to change the world. Their team of engineers and scientists worked tirelessly, transforming a simple mishap into a breakthrough technology that could revolutionize the energy sector. Instead of relying on the old, messy furnaces of the past, they designed a sleek, state-of-the-art reactor. This reactor is built specifically to split methane with maximum efficiency, using advanced materials and precision engineering. At the heart of the process is plasma, a superheated, electrically charged gas that reaches temperatures hotter than the surface of the sun. This plasma provides the intense, focused heat needed to break apart methane molecules in a controlled environment. Methane gas, which is abundant and widely available, flows into the reactor. As it encounters the plasma, the extreme energy instantly splits the methane into its basic elements. The result? Pure hydrogen gas is separated and collected, ready to be used as a clean, versatile fuel for everything from vehicles to power plants, with zero carbon emissions at the point of use. Meanwhile, the carbon that's left behind doesn't escape into the air. Instead, it drops out as a fine, high-quality powder. Solid carbon that can be used in manufacturing, batteries, or even as a soil additive. The entire system operates as a closed loop, meaning there's no waste and no harmful emissions released into the environment. It's a truly clean process from start to finish. What's more, Tulum's approach is designed to be highly efficient and compatible with the infrastructure we already have. Their technology plugs directly into existing natural gas networks, making adoption fast and cost-effective. There's no need to build new pipelines or overhaul entire systems. Tulum Energy uses what's already in place, minimizing disruption and maximizing impact. By producing both valuable hydrogen and solid carbon, Tulum Energy creates not just one but two revenue streams, making the process attractive for investors and industry alike. This dual output model makes the technology economically viable and easily scalable, so it can grow to meet the world's increasing energy demands. What once was a maintenance headache in a steel plant has now become a clean, profitable industrial solution, turning a problem into an opportunity. It's a testament to smart engineering. Simple, clean, and ready to be deployed around the globe, helping industries transition to a greener future. With their innovative process, Tulum Energy is leading the way in clean hydrogen production, setting new standards for sustainability and efficiency. And to think, it all started from a fluke in a steel plant, now transformed into a beacon of hope for clean energy worldwide. To see why Tulum's process matters, let's compare it to how hydrogen is made today. Most hydrogen comes from steam methane reforming, SMR, which creates lots of CO2, about 10 tons for every ton of hydrogen. That's gray hydrogen, cheap but dirty. Blue hydrogen tries to capture the CO2, but the technology is expensive and imperfect. Some emissions always escape. Green hydrogen uses renewable electricity to split water, making it clean but costly and energy-hungry. It's not yet affordable or scalable for global needs. Tulum's turquoise hydrogen sits in the sweet spot. It uses natural gas like gray and blue hydrogen, but produces no CO2, just solid carbon. It's cleaner than gray or blue and cheaper than green. Tulum's process can scale quickly using existing infrastructure. It's a practical bridge to a hydrogen economy. Clean, affordable, and ready now, not decades away. Turquoise hydrogen could accelerate the clean energy transition. Tulum is changing the game. Why all this effort for hydrogen? Because when you use it as fuel, the only byproduct is water. No CO2, no pollution, just clean energy. Hydrogen can power engines or fuel cells, generating electricity with zero emissions. It's a versatile energy carrier, like a rechargeable battery for the whole grid. Hydrogen stores renewable energy for when the sun isn't shining or the wind isn't blowing. It can decarbonize tough sectors like steel, cement, and heavy transport. Batteries can't do it all. Hydrogen fills the gaps. The challenge has always been making enough clean hydrogen, affordably. Tulum's breakthrough could finally make that possible. This could unlock the hydrogen economy and help save the planet. Methane pyrolysis flips the script on carbon. Instead of a waste gas, carbon becomes a valuable product, carbon black. It's used in tires, plastics, inks, and more. Tulum sells both hydrogen and solid carbon, making the fuel cheaper for everyone. This is value from waste, a circular economy in action. The solid carbon locks away what would have been CO2, storing it safely in products. It's a more permanent solution than trying to bury gas underground. Tulum's process turns a climate problem into a material solution. Clean energy, useful products, and less carbon in the air. Cheap, clean hydrogen could transform heavy industry. Steel plants could use hydrogen instead of coal, slashing emissions. Cargo ships and trucks could run on hydrogen fuel cells, cutting pollution from global trade. The chemical industry could make fertilizers with clean hydrogen, reducing agriculture's carbon footprint. Even aviation could benefit, with hydrogen powering short flights and sustainable fuels. This isn't just swapping fuels, it's a chance to redesign industry for a sustainable future. Tulum's breakthrough could unlock decarbonization across all these sectors. It's a key to a cleaner industrial world. The road to turquoise hydrogen isn't easy. Tulum's process still relies on natural gas, so methane leaks must be tightly controlled. Scaling up from pilot to global production is a huge challenge, requiring investment, partnerships, and new markets for solid carbon. The market for carbon black isn't unlimited. New uses must be found as production grows. Competition is fierce. Other companies are racing to develop similar tech. Tulum must innovate fast, protect its ideas, and build strong alliances. Success means overcoming both technical and business hurdles, but the potential rewards are massive. The clean energy marathon has just begun. The future for Tulum Energy and turquoise hydrogen is bright but challenging. Their next step, build a commercial-scale plant to prove the technology works at scale. Success could trigger more investment and rapid expansion. Turquoise hydrogen offers a practical bridge, cleaner than gray, cheaper than green. Imagine steel plants and cargo ships running clean, and new industries built on solid carbon. This innovation could reshape both our energy and material worlds. From a steel plant fluke to a global solution, Tulum's journey shows the power of curiosity and ingenuity. The hydrogen age may finally be here.